Alright, we'll finish up problem 1 in this video, part C. If the average rate of change of f on the closed interval 1 to 3 is k, then find the integral from 1 to 3 of sine of t squared dt in terms of k. Well, what we're looking for here is the average rate of change of f. So be careful, this is not the average value of f, it is the average rate of change of f. And how do we find the average rate of change of a function? It's the slope of the secant line connecting the endpoints. So the equation would be f of 3 minus f of 1 over 2, and that's equal to k. So that's one way of looking at the average rate of change. And we can get to our answer from there, but it's not as straight a path as we might want to see. So another way, which requires a little different approach, would look like this. If we were working with the derivative of f, then the average rate of change of f would be the average value of f prime of x. Or stated again, the average rate of change of f of x on the interval from 1 to 3 is equal to the average value of f prime of x on 1 to 3. F prime of x is the rate of change of f of x, and so the average value of f prime of x would be the average rate of change of f of x. So we do have f of 3 minus f of 1 over 2 equals k. That's one way of looking at it. Another way would be to find f prime of x. And again, by the second part of the fundamental theorem of calculus, f prime of x is sine quantity x squared. And finding the average value of f prime of x on the interval from 1 to 3, well, that would be the integral divided by the interval, or 1/2 the integral from 1 to 3 of sine of x squared dx. So these two quantities are exactly the same, and they're both equal to k. But since we're trying to find out what integral from 1 to 3 of sine of t squared dt or sine of x squared dx, it doesn't really matter which variable we use there. All we need to do with the second form is to multiply both sides by 2, and we have the form that we're looking for. Integral from 1 to 3 of sine of x squared dx is equal to 2k. And so that does it for parts A, B, and C on this first problem.